Hi, my name is Ariantasha. For PBT, I will present for task 1 and task 2. For task 1 introduction, as a network engineer assigned to set up the network for Polytechnic Seri campus in Pulau Pinang, you and your group are responsible for completing 7 tasks. These tasks involve configuring routers and switches, designing the network topology, addressing schemes, and documenting the network. The ultimate goal is to establish a functional and secure network infrastructure for the campus. Task 1 focuses on the initial settings, configuration for all routers and switches, including disabling DNS lookup, setting up password, enabling encryption, and creating a banner message. Task 2 requires designing the network topology based on the number of hosts per subnet. Using the information provided in Table 1, you will determine the required subnets and their respective hosts. In Task 3, you will perform subnetting and determine the network address and subnet mask for the given IPv4 address. Additionally, using Table 2, you will assign IP address for each subnet and create an addressing scheme table. Task 4 involves configuring the routers, host, and server using the assigned IP address from the addressing scheme table. This includes setting host names and configuring IP interface. Task 5 focus on configuring the wireless router for the student cafe network. This involves setting the SSID, password, enabling DHCP, and configuring IP address allocation for the clients. In Task 6, you will verify the network connectivity between different devices and subnets using EIGRP routing. By completing this task, you will ensure the successful setup of the network infrastructure at Polytechnic Seri, facilitating smooth communication and data transfer within the campus based on problem-based tasks. For Task 2, design location. Physical design. Physical design refers to the actual implementation of a system or component in terms of hardware, software, and infrastructure. It involves transforming the logical design into a physical representation that can be deployed and executed in a specific computing environment. The physical design takes into account the available resource, performance requirements, scalability, security consideration, and other constraints. First, network topology. The physical design determines the network topology, which defines how the network components are interconnected. It includes decisions about routers, switches, firewalls, and other networking devices, as well as the layout of network cables. 2. Server configuration. Physical design involves configuring the server according to the system requirements. This includes determining the number of servers, their specification, like CPU, memory, storage, and the deployment of redundant systems for high availability and fault tolerance. For 3. Storage design. The physical design addresses the storage requirements of the system. It involves deciding the type of storage technology like hard disk drive, solid state drive, network attached storage, and the allocation of storage resources to meet performance, capacity, and data protection needs. Logical design. Logical design focuses on the conceptual representation of a system or component independent of the specific technology used for implementation. It defines the functional components, their interrelationships, and the overall structure of the system. Logical design is often represented through diagrams, models, or other visual representations. First, system architecture. The logical design defines the overall system architecture, including the major components, their interactions, and the flow of data and control between them. It helps in understanding the system high-level structure and how the different parts work together. 2. Data modeling. Logical design involves creating data models that represent the structure and relationships of the data within the system. This includes defining entities, attributes, and the associations between them. Techniques like entity relationship diagrams or UML diagrams are commonly used for data modeling. For 3. Process design. Logical design determines the process or functions that need to be performed by the system. It identifies the tasks, their sequence, and the data transformations involved. Process flow diagrams or activity diagrams can be used to represent the logical flow of operations.
For each network device, go to the switch NCLA, then input the enable config T, no IP domain lookup, enable password 2023, line console 0, password PSN 2023, login. And another step is service password impression. After configure switch JTMK, now go to the switch JRKV and do the same step.
Hi, my name is Nur Fazila and I will be presenting about IP address table. Task 5. IP address for PSN G0/0 is 192.88.77.17. G0/1 192.88.77.33. For G0/2 is 192.88.77.1. For the S0/0/0 is 192.88.77.49. There are 8 PCs for JTMK and 4 PCs for JRKV. So for the JTMK PC1, the IP address is 192.88.77.18. So just +1 until the PC8, so that the PC8 IP address is 192.88.77.25. Same goes to a JRKV PC. For PC1, the IP address is 192.88.77.34. And the last PC4, just you need to add 3 more, so that IP address is 192.88.77.37.
Hi, my name is Nur Shafika and I will proceed to IP verification connectivity output. Verification connectivity output from JTMK PC1 JRKV to PC3. IP address is 192.88.77.36. Batch output successful. The second one is student cafe PC2 cafe WR. The IP address is 192.88.77.14. The result is successful. The third one is JRKV PC1 DBSRV. The IP address is 192.88.77.72. The result is successful. So the conclusion for playability is, by configuring routers and switches, designing the network topology, and implementing addressing schemes, You have established a functional and secure network infrastructure for the campus. Throughout the process, you followed best practice in network configuration, including disabling DNS lookup, setting up password, enabling encryption, and creating a banner message to enhance security. You also perform subnetting to determine the network address and subnet mask, and assign appropriate IP addresses to each subnet based on the provided requirements. The routers, host, and server were successfully configured with their respective host names and IP interface, ensuring seamless communications and connectivity within the network. Additionally, the wireless router for the student cafe network was properly set up, enabling clients to connect securely and obtain dynamic IP addresses through DHCP. To verify the network's functionality, you conduct connectivity tests between different devices and subnets, utilizing EIGRB routing. By ensuring successful communication and data transfer, you have established a reliable network environment for the Polytechnic Balikpapan campus. Overall, through your diligent efforts and effective collaboration as a group, you have accomplished the goal of setting up a robust network infrastructure for Polytechnic Balikpapan. This will enable smooth operation, enhanced communication, and efficient data exchange within the campus, supporting the institution's educational and administrative activities. Thank you.